Hello, everybody. Sorry, no music today. Got a little behind. Had someone come in for help. So we're getting right into lesson 6 in unit 4, talking about exponential modeling with percent growth and decay. So what we're looking at is we're looking at values increasing or decreasing by fixed percentages. All right, over a given units of time. Now, usually the time is years, but it doesn't always have to be years, especially when we get into half-life. So you saw this in Common Core Algebra 1, and we'll review much of what you have seen in the past, just a little refresher. So in exercise 1, suppose that you deposit money into a savings account that receives 5% interest per year on the amount of money that is in the account for that year. So assume that you deposit $400 into the account initially. So you start with $400. How much will the savings account increase by over the course of the year? So if it receives 5% interest per year, it is 5%, which is 0.05, times 400, which is $20. So that's how much the savings account will increase. How much money is in the account at the end of the year? Well, that's just 400 plus the 20, so $420. By what single number could you have multiplied 400 by in order to calculate your answer in part B? Now, what you could do is you could do 420 divided by 400, and you would get 1.05. So you can see the 0.05 is from the 5%. The 1 is the $400 that you add to the 20 to get $420. So using your answer from part C, determine the amount of money in the account after 2 and 10 years. So if we had the 400 times 1.05, that would be after 1 year. That's how we got the 420. But now we're going to raise it to the power of 2 because it's after 2 years. So you have to do 1.05 times 1.05. And that would give you $441. Same thing with 10. We would do the 400, 1.05 raised to the 10th power, and that would give you $651.56. Remember, with money, you want to round to 2 decimal places. Now an equation. If you want an equation for the amount of savings, S of t, as a function of the number of years since $400 were invested. So S of t, your 400 is the initial amount, which we're going to see in a formula soon. And then it's 1.05 raised to the t power. Using the table in the calculator, how long will it take the investment to double? Okay, so if we want 400 to double, we are looking for an S of t that equals $800. They want you to use your calculator, so there we are, 400 times 1.05, and you got to raise it to the x power, not the t. Enter, and should we see anything? No, we should not, because we start at 400, then it goes up to 420, and it keeps increasing. So when you go to your table, Control T, all right, we want to see where it's going to double. So we want to see when you get to $800. So you're right about here, 14 to 15. If it says to the nearest year, so what we need to do here is edit table, menu table, edit table settings, start, we're going to do the table step by the 10th. We want to round to the nearest 10th. Table start, we're going to start at 1, and then we're going to OK it. Okay, so there's your 1.1. All right, all the way up. We got to see where it's doubling. So we want to get to the 800. And you can see that it hits 800 right about here, between 14.2 and 14.3. So if I round 14.2 and 14.3, that, of course, is going to round to approximately 14 years to double. Now, the formula that I was talking about is this formula right here. I don't like the formula that he uses. So the formula that I'm going to use is A of t equals A times 1 plus R to the t power. A of t is how much money you have after a certain amount of time. A is your amount that you started with. your principal. 1 plus r, the r is the rate, and t is the time, like I said, generally in years, not always. And this is called a growth model. All right, growth because we have an addition sign. So that means we're going to increase. So exercise 2, which of the following gives us savings S in an account if $250 was invested at an interest rate of 3% per year? Now, the key thing you have to be very careful of is my rate is going to be 0.03, not 0.3, like they have in choice 4. So if you follow this formula, my A is 250, 1 plus R is 1.03, and it's raised to the T power. So the one that has 250 first, and then it's got to be multiplication, 1.03, these are all different, and then raised to the T power, so it's choice 2. Now we also have decreasing. So we have growth and decay is how we refer to it. Decreasing exponentials are developed in the same way, but they are subtracted rather than added to the base of 100, or 1. Because it starts at 100%, but you change it to 1. So you ultimately multiplying by the percent of the original, they will have after a time period elapses. So what happens is, I'm going to state the multiplier. Just state the multiplier here. If we decrease by 10%, so that means that 10% is gone. So what is left is 90%. And how you get that is doing 1 minus 0.1 to give you 0.9. Okay, and that's the multiplier. Same thing here would be 1 minus 0.02, so it would be 0.98. 1 minus 0.25 would be 0.75. And then be very careful here, because this is actually 0.005, because it's 0.5%, and that gives you 0.995. And of course, by all means, put that in your calculator. We don't want you to make an error doing 1 minus 0.005, doing it in your head. We don't want to do that error. So decreasing, essentially the same exact formula. And you have A of t equals your A, again, which is the initial amount. But this time we are subtracting the rate and then raising it to the T power. Okay? So exercise 4. Population of a town is decreasing 4% per year. Started with 12,500 residents. Which of the following is the projected population 10 years? Show the exponential model you use to solve this problem. So my exponential model, and if they don't tell you, you can always use A of t. Okay, so A of t. A is the initial amount, 12,500. If you need to show exactly as it is in the formula, 1 minus 0.04, and the time is 10 years, which is the same as 12,500.96 to the 10. And just put in your calculator that exact way. And when you put in your calculator, you will see that you get choice number 4. Okay? Now this last one, I don't think I have the graph here. We have the stock price of Wind Power Incorporated increasing at a rate of 4% per week. So we have Wind Power, it's increasing 4%, 1.04. Its initial value was 20. So we have 20 and then 1.04 and to the T power. On the other hand, the stock of Gerbil Energy is crashing. So G equals at a rate of 11% per week. So it's losing value. So that's going to be 0.89 because it's 1 minus 0.11. Its price was $120 per share when Wind Power was at 20. So after how many weeks will the stock prices be the same? So now we're into weeks. Like I said, the T usually is years, but sometimes it'll be weeks, it could be days, it could be hours if you're talking about half-life. Okay? So we want to draw a well-labeled graph to justify your solution. So what we're going to do is we're going to go to the graph page. So I'm plugging in. I plugged in the first one, 20 times 1.04 raised to the x power, entered it. Now I'm going to tab it and put the other one in, which was 120 caret 0.89, and that is also going to be raised to the x power. Enter. Okay. So we're going to zoom out Analyze graph, and we're going to zoom. No, I wanted a 4, sorry, window zoom. Okay, so we're zooming out here, and it's got to be in the first quadrant, so we zoom out, see what's going on here. Okay, so that's the intersection point, which is what we need to see. It says draw a well-labeled graph to justify your solution. So you can see we have increasing and decreasing based upon the value in the parentheses. As we looked at exponential growth and decay previously, based upon your basic graphs. So I'm going to do Control T, and you can see your two y-intercepts right here at 20 and 120. So you see those values. All right, so we have 20 and 120. So I'm going to escape this, and I want to find my intercept. So I'm going to remove the table. Remove you. Okay, and we're going to find that menu, analyze. Now it's analyze graph. The intersection, lower bound is here, upper bound is there. And it's 11.5 and 31.4. So if you go to the graph, okay, I'm going to get down here, extend my page, and we'll just draw a couple lines here. This one here, this one here. Okay, so we had 20. So we're going to say that that's 20. And the other one was 120. So it's all approximate. Okay. They need to, this one was going up like this. This one was going down like this, something like that. And this coordinate here is 11.5 and 31.4. That's the intersection point. Okay. Now, what happens is we don't show to the left of it because that would be like negative time. And we're not talking about that. We're talking about weeks from the starting point. So that's why we start at the y-intercept. And that is good enough for me to sketch it. The only thing you would do, of course, is you would label. And this one would be 20. 1.04x, and this one is your 120. It's got to be, I got to put y equals 120.89x because I'm using x's and y's. So you just got to make sure they're both labeled, and there you go. All right, and that's good enough. All right, so watch it in class. Hopefully, I don't want to give you any homework over the weekend, so hopefully you get everything done in class. All right, I will see you next time.